more problems to understand how the polar coordinate system works. So in this problem, I gave you a polar coordinate r is equals to 6, theta is equals to pi over 4. So what I want you to do is I want you to plot this point and then find two other pairs of polar coordinates of this point. One with positive r and one with negative r. So let's plot this point. I can't use yellow because it's too hard to see. So 6 pi over 4, 0, 1, 2, 2, 3, 4, 5, 6, 7, 8. Pi over 4 is right there. So this is the point that we have. So the plotting is done. Now, I want to find one positive and one negative. So we do the math. So r is positive. So how do I find another point? I'm not looking for another point. I want to write another coordinate. That coordinate has that pink point too. So r, I will just use the same r because they want rate positive, right? 6 itself is already positive. In order to go back to the same point, you have to add 2 pi to it. So you have to do a pi over 4. And then you add 2 pi to it, so that is 6 comma, so that will be an 8 plus 1, 9 pi over 4. So how's the, what is adding 2 pi mean? So go back to pink, so add 2 pi means you just add one full circle to get back to the same point. All right, so let's erase that, I've seen it. One full circle to get back to the same point. And then we want to do a r less than 0, so that means we have r equals to negative 6 then. So we have a negative 6. So this negative 6 is fixed. There is nothing you can do. So what happens if you change that to a negative 6? So if you change that to a negative 6, that means you have to go from quadrant 1 to quadrant 3. So you have to reflect 180 degrees, right? So you have to reflect 180 degrees. That means you have to add a pi, or you add 180 degrees. So that means you have the 45 plus 180. So that is equals to 225. So instead of here, we have here, right? So if you change that to a negative 6, but this point is not the same as the point we have at the beginning, right? So we have to do some works for it. So how do I go back to that point? Because this point and the given point, they are not the same. Not the given point, the point that we just plot. They are not the same point. How do I go back there? So to go back there, you have to take 180 degrees. So that means the math, we have to take the pi over 4, and then we add a pi forward. So from this point, we add a pi forward, then we get back to that point. So that is equals to negative 6, and then a 5 pi over 4. All right, so that's the first one. And then we have B. B, we use another color to do it. So in B, we have negative 4, and then the angle is 3 pi over 2. And then I already prepared a polar pink right there. So let's bring it up. Negative 4, 3 pi over 2, 0, 1, 2, 3, and 4. So 4, 3 pi over 2, it is right here, right? But you have a negative 4. So 3 pi over 2 was there, so negative 4, that means you have to reflect 180 degrees. So that means you have to be in here. So this is the point of the polar coordinate. So let's erase this. So now we have a point. So what are they trying to do? They want me to first, let's keep a negative r. So this negative 4 itself is already negative. So how do you get back to the same point? So to get back to the same point, you stay at that point. So you take whatever the angle is, and then you plus 2 pi to it. So that is equals to negative 4, and then 7 pi over 2. And then what happens when r is positive? So that means you have r equals to 4. If you use r equals to 4, what do? Then this will be a 4. Then this will be a 3 pi over 2. If you take a 4, that means you have to reflect 180 degrees back. So you just reflect 180 degrees, right? So that means you add 180 degrees back. So in order to go back, because just think about this. You start at 0. I force you to take 180 degrees forward. How do you go back to the starting point? Easy. You subtract 180 degrees. So that means you're starting at where you are, you take one step forward, and then you take one step back. So you just get back to that point. So that will be 3 pi over 2 minus pi. you have a 4 comma pi over 2. 4 comma pi over 2 is the blue point right there, right? So that is problem 3 and problem 2. And then problem C, I will copy that problem for you. So problem C, we have a phi, right? And then negative pi over 3. So C, we have a phi negative pi over 3. I already prepared a polar plane. So that is right there. Let's copy that. And then we paste. So I can use that for the next problem. So phi 0, 0, 1, 2, 3, 4, and 5, and then pi over 3. So this is pi over 3, but negative pi over 3 is clockwise. So that means we are right here. So phi, and then we have this point. So the point is there, and then what we want to do, so we want r greater than 0. So that means phi stays as a phi, right? So phi stays as a phi. And then how do you get back to the same point? So whenever you are, just take 3, you just add a 2 pi. So you spin a full circle to get back to the same point. So here is how the math works. You are at that orange point, right? You spin a full circle, then you get back to that point. Let's erase that. So that is 5 pi over 3. And then when r is negative, that means I force you to make the phi negative. Force you to make the phi negative. So when I force you to make a negative, to make the positive phi negative, that means you have to reflect 180 degrees. That means you have to go from quadrant 4 to quadrant 2. Right? So that means you have to take 180 degrees. How do you go back to quadrant 4? I force you to do it. So whenever you are, let's say you are at 0, I force you to take a step forward. How do you go back to the starting point? You take the same step back. Standing and where you are, you take one step forward. How do you go back? You take one step back. It's just that easy. So you force to make the phi negative, but whenever you are, you take a step back, then you have a negative phi comma 2 pi over 3. So that is the end of this video. If you think my instruction is helpful, like, subscribe, and share. Appreciate your help. Signing out for now. I see you all in the next video.